So, throughout morning we heard about industrialization and the effects of industrialization, the features of industrialization which try to establish its control over nature for meeting human needs. Urban livelihood, which is an offshoot of industrialization, has come with the side effect of overuse and disposal of all kinds of resources and products. So the treatment of these products and resources, wastes generated from those that overuse and over disposal of resources is the most challenging issue faced by human society today. Further, the treatment of liquid waste is all the more difficult because of the malign effects it has. And what could be a solution for this? Can we try with lakes for a possible solution? I think a lake called Jaipur Lake in Bangalore has set an example for this. So my objective of this small case study is to see the changed functionality of Jaipur Lake that has transformed into an urban lake from a rural lake. And the functionality is suiting the changed urban, the changed settings, that is urban settings. So introduction. A lake is a still water body of considerable size surrounded by land and is the most productive ecosystem. And lakes are of many kinds, and basically they are of two types, man-made and natural. Natural is the one where the water gets collected in natural depressions, and man deliberately makes depressions, that is a man-made lake. And Jaipur Lake is a man-made lake existing in the northeastern part or outskirts of Bangalore city. It was a rural lake till year 2003 and an urban lake from then. So the methodology I've used for this case study is we have spoken to the fishermen living in the premises of the lake and residents living in the villages around the lake. And the secondary data was collected, that was the primary data and secondary data collected from various departments that are affiliated with lake administration. Bangalore Development Authority, Bangalore Water Supply and Sewerage Board, Brihat Bangalore Mahanagarapalika, that's the corporation, and Lake Development Authority, and of course, review of literature. The history of the lake in brief, it's more than 200 years old, and the construction, the building details of it are not available. And it used to be a main source of irrigation. Very seldom, it also used to be a source of potable water for the villages around. It used to be a source of food it used to be a main source of fishes for them, and a deity of worship also. We Indians do worship water, so it also used to be a deity of worship, especially after rainy season. Once the tank used to get filled, people used to offer worship to that. In 1980, a wheel and axle factory came up in the neighboring Yelahanka town that resulted in severe pollution of the lake that reduced it to almost a gutter. In 2003, the Bangalore Development Authority took over the fields, agricultural fields around the lake that were getting irrigated for the construction of a residential layout called Arkavati layout. And in 2006, the Bangalore Water Supply and Sewerage Board set up a sewage treatment plant in the premises of the lake. In 2009, the BDA, the Bangalore Development Authority, again took up the regeneration task of the lake and finished it in 2011. Sewage treatment plant that is set up in the premises of the lake has a capacity of treating 10 million liters of sewage a day, but is treating only 4.5 million liters of sewage that is reaching the lake, not more is reaching the lake, and it's a secondary sewage treatment plant. Rejuvenation of the lake that was done by the Bangalore Development Authority that encompasses survey, fixing, fencing of boundaries, high stone masonry, creating wetland, desilting, providing revetment, putting silt tracks, screen barriers, idle immersion pond, making of food kiosks, construction of boat jetty, and plantation work in the area of the lake. And this is the brief morphological details of the lake. And the full tank level here I want to highlight is about 888.3 million liters of water after desilting. So this is a satellite picture of the lake. So the ecological services of the lake. Traditionally, lakes were built for water supply. That's pisciculture, that's fish breeding and flood control, silt extraction, recharging of aquifers, natural water quality improvement, maintenance of relative humidity. In addition to performing all these tasks, the Jagpur lake, which is now an urban lake, is also performing the task of hydrotherapy. There are several apartments that have come up on the shores of around the lake, and the apartments that face the lake are costing more to the customer. So that is profiting the landowner and not the exchequer. Recreation and ecotourism. Of course, where several citizens use it, and it's also a breeding ground for birds now. So that's also not encashed. And above all, and the most important issue, the wastewater management is being performed by this urban lake that was once upon a time a rural lake. So what does this wastewater management, how does this wastewater management help Bangalore's water woes? Actually, the Bangalore's water woes are shortage. Bangalore needs about 1350 million liters of water a day, and it's only getting supplied with only 1150 million liters of water, falling short of 200 million liters of water a day. High cost of water supply, it's taking about 32 rupees per kiloliter to supply water to the citizens for the exchequer, and they are giving it at a rate of just 24 rupees, bearing the loss of 8 rupees per kiloliter, and leakages and loss of water in the process of supply, that's about 40%, shocking. And inequitable distribution of water, still the outskirts of Bangalore is not getting supplied with water by the government. And alarmingly high amount of water mining is happening in Bangalore. There are about 3 lakh borewells or tube wells in Bangalore alone. And water pollution I need not give any description about it. All cities are undergoing this, and Bangalore is no exception to it. And findings, there are about 10 bore wells and 10 open wells in the surrounding area of this Jagpur lake. They are all owned by the private players. They are taking advantage of this. They are selling water from these wells. And the water of these wells have very good, the water of these wells are of really good quality because of the water getting treated in the sewage treatment plant. Again, the lake is also processing it, refining it. So the water in the wells is of very good quality, and that could definitely be used for potable purposes also. And moreover, the chemical analysis of water has shown that the lake water itself does not have anything in exceeding quantities apart from chlorophyll and just aluminium. And conclusion, this is the story of one of the 262 lakes that were there in Bangalore, of which only 81 are surviving and of which only 17 are in quite okay condition. So India's wealth of her past attributed to the availability of water, especially availability of water always at all times and at all places, so which boom the economy. So this can also be replicated even in the modern times. Lakes are not a luxury for urban areas, but it's an utterly essential need of the hour. Thank you very much.
Sitting in some other session waiting for the presentation, Mr. Kumar and his team. Dear Raj has not turned up it up yet, according to the organizers. 2 are here. I'm thankful to both Professor Krishna and Shruti Srinath and Bhakti. Now we are open to the discussions. You can raise the questions first, and you can mention to whom you are asking this question. They will write down the set of questions, then together they will answer. Feel free There is one on the groundwater, inequality, inequity in Tamil Nadu and Punjab. That's what Professor Krishna here mentioned. There's one on the lakes, urban lakes, rejuvenation. That's what Shruti Srinath has presented. And its importance in an urban area. You are free to raise any of the questions to any of them. Yeah, please.
I have a question for Mr. Shruti. It would be nice if you could just let us
If you're talking a little loudly so everybody can hear.
Okay. My question is for
You see, coastal area there are very less pump sets and tube wells as far as Tamil Nadu is concerned. And therefore the areas which are close to like Tanjavur or Nagapattinam and things like that, so the areas which are closer to sea areas, they grow paddy, but the yield is very less as compared to those areas which have sweet water and things of this kind. And therefore there are normally no induction of, because you see that. But then there was an impetus to that with the era of globalization, that prawn cultivation, you see, took place on a large scale, both on the coastal belt of Tamil Nadu as also Andhra Pradesh. As a result, what happened that lot of pump water was being piped even for, you see, the prawn farms. And as a result, there was pollution of saline water and fresh water. And so that affected drinking water considerably, and there was large-scale protest also for that both in Andhra Pradesh and also Tamil Nadu. And therefore, you see that adverse effect was there.
Any other questions? Either in the lakes or groundwater?
One question for Sati. Sati, you have tasted water.
Introduction, please.
Yeah, but then as far as Punjab is concerned, you see, you will find that the large farmers invariably feel that they also own groundwater, and therefore they are inducting submersible pump, and then they are overdrawing the groundwater in the land which is below them.
So the problem is what you are reading is one thing, but what actually officials like them will execute the order is most important, because they don't have anything in the writing, like a government order or an act, Groundwater Irrigation Act, which enables you to say, or to the landowner to say that it belongs to you. It doesn't say anything. They only have a spacing norm or a depth norm.
Yeah, but then you see there is hardly any groundwater act which is being implemented.
But it in fact, it has helped in the Bangalore in many lake studies. That's the whole idea. It's a small contribution in that direction.
Because in Varanasi too, we have lots of ponds and they have been encroached and have been
Exactly.
threatened.
Yeah.
And they have been completely, we have minimized the ponds culture which Varanasi region had. So that's why I was asking what
Sure,
is the
you're most welcome. You should ask more questions. Probably you should sit with the Shruti and analyze what the Bangalore did it, several other studies, Ahmedabad did it, House is doing it now in Delhi. First of all, fencing it, the lakes. You find it in surroundings of Mumbai and Pune. You look at it. First of all, they don't fence it. So it's whoever encroaches, it belongs to them. So the what country after country, state after state, you first recognize your boundary.
In Mumbai, in spite of having heavy rainfall, groundwater is not getting
Correct.
discharged.
Yes.
Due to concretization also. Runoff.
Exactly.
Yeah.
Exactly. Yeah. So first of all, identifying the property, fencing it, protecting it, then rejuvenating it. First stop arrest growth of the problem, then start treating the problem. That's what they're trying to do it. That's what this small study indicates. The current status, its problem identification, then all this multidimensional analysis of the problem, then what are the possibilities in the future. That's a small effort in this whole direction, but it's possible. Yeah. Any other questions now?
Do groundwater rights lead to excess extraction?
No. There are two ways of doing it. First of all, one is identifying the rights. Second one is its regulation. Okay. Now, new groundwater bill, if anybody interested, take a look at the CGWB and other states. Yeah.
I am from Mumbai.
Little loudly so people can hear.
I am Mr. Manoj Jha from BMC.
BMC stands for
Working as a senior scientific officer
Bangalore, Mumbai,
Municipal Corporation.
Brohat Mumbai Municipal Corporation. Yeah.
My question is to Krishna Iyer. In future, Sati land can use agriculture again, and what treatment should be done on Sati land for agriculture?
You are asking that how salty land.
Saline land, basically.
Can be used for cultivation. You see, I will confine to Punjab. So in Punjab, you see, we have two problems. One problem is the extraction of groundwater, and the second is saline water. Because Punjab is divided into three regions. One region, central Punjab, you see, is having a lot of submersible pumps. The other is the Sabini, and third is the southwestern Punjab. In southwestern Punjab, you have the problem of water loss, and then you see water being found at every island. And so, due to that water is, and that entire water is saline. And now there is the danger that that saline water is gradually flowing into also the sweet water of the central region. So that is the danger of that being. But then what they are doing, that since there is large saline, large land under saline, both in Punjab and Haryana, so they are doing treatment for that. And gradually you see they are bringing that back into cultivation paddy. And that's a systematic effort for the last 30, 40 years going on. And they have been, they had a limited system.
Saltwater interface depends on
Little loudly. You need to introduce yourself first.
so my name is Umesh Gaurav, exact Bangalore. The saltwater interface in terms and it depends upon the depth of the bore. When people go more about deep and deep, this saltwater, especially the coastal part of the area, entrance to the groundwater. So it will be useful for the agriculture purpose or whatever other purposes.
Because you see, in Punjab and Haryana, wherever there is large area which is saline water, they don't use it for agriculture purpose. They cannot use it for agriculture.
Also, you can see is taken up in the depth of the
Depth,
if you go more deeper, there is some like it and it
Yeah, very possible, but at least you see, in central Punjab, they have dug very, very deep. But still, the saline water something, they have not been found. But that would be true as far as the south, and that would be also true for the coastal areas. You see, if you go deep, then you will get more saline water and sweet water. You see, as you are nearer the sea, you will find a lot of content of sea water for drinking water. As you go deep, then the water will be more saline.
What we will do is, people need a break. There's a 15 minutes break schedule before the next session starts at 4:15. Another set of 4 sessions. Thank you very much for your active participation and to presenters.
Of indigenous plants used for water treatment by rural communities in southeastern Nigeria.
Can you speak to the mic?
Many studies have shown that in developing countries, water drawn for human consumption and several household uses and industrial uses will be highly troubled, particularly during rainy seasons. Because during rainy season, the rain wash off from farm fields these chemical fertilizers, manures, and some waste into the river body. Some pollutants may include pesticides applied to farm fields and home owners' lawns, manure and chemical fertilizers containing nutrients such as nitrates and phosphates, mining waste and sediments, solid materials, microorganisms, as well as industrial waste. In urban centers, water authorities use chemicals such as aluminum sulfate to solidify into particles, which are then removed and treatment works. For this available to the rural communities. And when they are available, sometimes they are not accessible to the rural people, and they are forced to drink polluted water, after which there is a lot of outbreak of waterborne diseases. And because of this, we have tried in some scientific researches to develop alternative water treatment methods that can be used in the rural areas, not allowing them to consume the polluted water, waiting for government, which most of the time this water treatment is not available to them. So the development of such readily available alternatives will be based on known traditionally water clarification capabilities of native plants. The seeds of many plants native to the tropical parts of the African continent contain essential oils and demonstrate coagulant properties that may clarify water, containing relatively high levels of suspended solid and disease-causing microorganisms. Among these is the ability of certain seed extracts to flocculate particulates in water. In this study, the value of 4 indigenous plant seeds of southeastern Nigeria in the clarification of relatively turbid stream water was investigated. 4 of these plants, because there are many of them, but we just worked on 4 that we found very effective. Moringa olivera, Z-maize, Sphenos denocapa, and Tetrachlora tetraptera. In each case, the seed pods were allowed to mature and dry on the plants, parent plants, and then harvested, and the seed kernels sun-dried to allow for grinding. Then they are ground into powder with electrical blender and sieved in mesh. The prepared seeds were then stored in tightly corked and properly labeled plastic bottles. Then, the water samples were collected from a major river that traverses through the city where I reside. It's not a city per se, it's a local community where the university is situated, but it serves the populace for so many purposes. So, 16 metal buckets were sterilized, cleaned using cotton wool soaked in ethanol, and then incubated for 30 minutes at 120 degrees centigrade. Then the water samples were directly sourced from Otamiri River at a rural community drinking water collection point during morning hours. The collection proper was done by dipping the bucket below the surface and then properly covering the bucket immediately. The buckets were then transported to the laboratory where treatment and analysis were carried out. The finely crushed seed powders were individually mixed with clean water to form paste and were then diluted to the required strength. The solution was then shaken for 5 minutes in order to release the chemicals in the powder. Insoluble material were filtered out using either a fine mesh screen or muslin cloth into the bucket containing 10 liters of water to be treated and stirred rapidly for 2 minutes, then slowly for 10 to 15 minutes. The treated water was then left to stand And after the solid materials had settled to the bottom of the bucket, clean water was in each case carefully collected for physicochemical analysis in sterile plastic container after 1 and 24 hours intervals of treatment. So the experimental design was done this way. Raw drinking water, that is the natural, the untreated one, was used as control. Then one stood as a control to compare, because in a place they use alum most of the time, and alum is part of the chemicals that we are trying to dissuade people from using, and encourage them to use natural products that may not be detrimental to health. Then 1 gram Moringa oleifera was introduced into 10 liters of water. All the buckets contain 10 liters of water. Then the treatment was done 1 hour in 1 hour time period for the different seeds. Then for 1 gram, then 2 grams in the same 1 hour treatment period, and then 1 gram again in 10 liters for 24 hours, and 2 grams for 24 hours to see which the variables that will occur in the different treatment, as to be able to advise the community better. And all reagents used were of analytical grade, and standard procedures were followed in the analysis of alpha. Physical parameters determined were electrical conductivity, color, turbidity, total dissolved solid, odor, taste, and temperature. We are now working on the biochemical analysis. But this is, we just worked on the physicochemical analysis before I started coming for this conference. Chemical and parameters determined were pH, dissolved oxygen, hardness, acidity, alkalinity, chloride, sulfate, copper, ion, were determined using atomic absorption spectrophotometer. Data generated were organized in tables and compared with standards recommended by WHO 1995. Thereafter, percentage reduction of turbidity over time in the treated water using the different seed treatments was calculated. Next. Oleifera, Z-maize, African bean seed, and tetraptera seeds at different concentrations, and the duration of treatment are presented in table 1 to 4. The source water exhibited turbidity level of 58 NTU, which was greater than the WHO standard of 50. However, treatment with 1 gram of the various seeds over a period of 1 hour showed that pH remained within the range of 5.03 in African bean seed, that is phenol treated water, to 5.12 in tetraptera treated water, indicating slight acidity. These were different from the more acidic water 3.66 produced from alum treatment, and similar to the raw water sampling. Values for TDS and that's total dissolved solid and total suspended solid were below the WHO standards for both the raw alum and seed treated water. Specifically, raw water and alum treated water values were 61 milligram per liter for TDS and 32 and 16 for both TDS and TSS respectively during the 1 hour treatment period. These values were significantly reduced further by the various seed treatments to ranges of 36 to 52 milligram per liter for total dissolved solid, indicating that Z-maize and African bean seed powders are better total dissolved solid treatments, and TSS 9 and 5 milligram per liter respectively, as table 3. Comparison for the phytochemical characteristics of Otamiri River treated with alum and 1 gram per 10 liters of some tropical plant seeds for 24 hours were presented in table 3. It is interesting to know that with increasing treatment period, there was observed pH change in the African bean seed, that is Stenos stenotapa, and tetrafluoride tetraptera treated water, which became slightly more acidic, 4.95 and 4.88 respectively. For the Z-maize, the water became more basic. Over 24 hours treatment, both the TDS and TSS values of Moringa oleifera treated water show some change in values when compared with the values obtained during 1 hour treatment, 52 to 38 mg per liter TDS and 19 to 17 milligram per liter TSS, indicating period of treatment is an important factor in the use of these seed powders for water treatment. The rate of turbidity reduction was found to be higher at lower doses and 1 hour after treatment process than it was with increased dosage and longer period of treatment. However, the reverse was the case with Moringa oleifera and tetrafluoride tetraptera seed powder that gave reduced turbidity levels with increase in dosage and settling time after treatment. The best turbidity reduction was achieved with Moringa oleifera seed powder after 1 gram treatment for 24 hours, while 1 gram treatment with Z-maize for 1 hour reduced turbidity by 81%. Some of the plants was found out to quickly treat water within 1 hour, like the Z-maize, after which the powder begins to degenerate. So in that case, if the water is going to be consumed or used within 1 hour, then it is better to use Z-maize, that is corn. But if it's going to stand for a longer period, then it is advisable to treat with tetrafluoride tetraptera or Moringa oleifera. So that is what was found out. That some treat and keep water over time, while some just treat for a short time. African bean seed powder, on the other hand, achieved poor turbidity reductions of 39.0 and 37.9% at 1 gram treatment for 1 and 24 hours period respectively. While tetrafluoride tetraptera seed powder recorded 56.9 and 62.0% reductions after 1 hour and 24 hours treatment respectively. Seed kernels are known to contain significant quantities of a low molecular weight water-soluble proteins, which in solution carry an overall positive charges. When added to raw water, the proteins bind to predominantly negatively charged particles that make raw water turbid, such as silt, clay, microorganisms. Under proper agitation, these bound particulates then grow in size to form the flux, which may be left to settle by gravity or be removed by filtration. Some insoluble materials from the plant seeds were suspended in the treated water samples and were believed to have escaped through the mesh screen into the bucket and added to the TSS of the sample. In practice, therefore, there may be need for provision of a filtration system. This laboratory investigation have confirmed the seed, especially maize and tetraptera seed, to be highly effective in the removal of suspended solids from water containing medium to high initial turbidities. Thank you.
Thank you very much, Dr. Rakani Grace, for the informative presentation, which is related to water treatment. And now the session is open for question answer. If there is any question, you may ask regarding this presentation. Any questions? Okay, yes.
I'm Mrs. Fitness from Municipal Corporation of Greater Mumbai. My question to you is, madam, are these species seeds available in India here? You said you need to process the seeds and make it in the powder form. So what is its shelf life? And one more question. Bombay Municipal Corporation is treating water with alum, but our requirement is 3,000 million liters per day. So, is it feasible to go for this type of thing?
The first question is if the plants can grow in India.
Can you take other questions?
Is that?
Can you take other questions?
Yeah.
Moringa oleifera grows in every country, yes, because it is in the literature. So it can grow in India. I think it is even available in India. Yes, I've seen it in literature. There was the second one, the shelf life. Yes, if the seeds are properly left to mature properly on the plant, parent plant, and harvested, then if they are properly sun-dried and kept airtight, yes, they can stay for 2 years, 3 years. They are properly dried and stored carefully. Okay, you talked about it. Yes.
Because you have done this on for 10 liters.
10
laboratory
liters.
scale.
Yes.
So application of this.
It is
on
achievable. It is achievable. Because alum was provided for such quantity of water. So this can also be achieved if the government is interested in it.
Okay, thank you very much. Okay, you can ask one more question. Once again, let me just ask whether any one of the speaker of this session is present, like Venkatesh Datta, Sadiki Lotha, and K. Bhaskar. The three are the three speakers of the papers. I think they are not present. So thank you very much. Thanks a lot for coming. As well as let us join to other sessions. I think they are considering them.